Yes, we are going to start now Unit 4, Partial Differential Equation PDE. Little bit, it is similar to the LDE. We'll discuss about it on the next slide only. So again, the weightage of the topic is 17 marks. So this one is the second last chapter from our syllabus. After this, we left vector calculus again. So that about last unit. So come to the topic PDE. So this one is just a flow diagram for getting what are the articles you are going to complete it in the PDE here. So the PDE is mainly divided in our syllabus as a first order and higher order. Okay, it is exactly similar to LDE also. In LDE also we learnt about first order and higher order LDE. Okay, so higher order LDE we are solving by CF and PI. So exactly same thing we have here. PDE also we are going to find out by CF plus PI as a complete solution for higher order partial differential equation. Generally, this part is coming for 5 marks in final exam, higher order PDE with a CF and PI. So method is exactly similar to the LDE only. Just like LDE only, we have to solve it for this PDE. So that is one thing. Another thing now, first order PDE. In first order PDE, we have non-linear and linear PDE. So for solving a linear first order PDE, only one method is there, which is known as the Lagrange's method. Okay, and here we have total five methods for non-linear first order PDE. Out of that, this Charpit method is the most important method. One 5-mark question is always coming on Charpit method. One 5-mark question comes on higher order PDE, and remaining 5-mark questions are coming on this 5 method. So 1 to 4 plus Lagrange's together have the 5 marks weightage there. So that's everything is written here only. So you can see that. So what I want to say here, in LDE, this the topic that LDE, we have a linear and higher order. Okay, linear and higher order. So in higher order, we calculated it by CF plus PI, and we have there near about 15 marks weightage for this part. And in linear, we have that exact differential equation, exact and linear differential equation, which have the 2 marks weightage there. So that about in LDE. But for PDE, now higher orders have the 5 marks weightage. This part have near about remaining 12 marks weightage, first order PDE. Okay, so we'll go one by one on these articles and how we can use these methods. We'll come to that. Okay. So before we start the topic, let me first go through the notations which we are going to use in this topic. So the first part is important here. These are the notations. So throughout this topic, we have a variable z as a function of two variables, say x and y. Z depends on x and y. Z is a function of x, y. And now we can differentiate z partially with x or partially with y. So when we differentiate partially with x, we say dou z by dou x. We are going to denote this partial derivative by a letter p. So small p indicates dou z by dou x. Similarly, small q indicates dou z by dou y. So this is the notation just we are using for partial derivatives. So P, Q are the first order partial derivatives, which you can observe here also, that P and Q, and remaining three, which are dou 2z by dou x square, we denote it by R, dou 2z by dou x dou y is S, and dou 2z by dou y square is T. So these are the higher order or second order differential coefficients. So in general, or in short, we denote PQRST for first order plus second order partial derivatives. So throughout this topic, the question can come in the two forms. The question can come like this: solve the differential equation. Solve the differential equation dou z by dou x plus dou 2z by dou x dou y is equal to 0. Suppose this is the question that we have. Solve this differential equation. Or the same question can be asked in this form. Solve dou z by dou x, we denote it by p. So p plus dou 2z by dou x dou y, yes, we can denote it by s. So solve p plus s equal to 0. P plus s is equal to 0. But remember, this p and s are not just numbers, or it is not algebraic equation. It is a partial differential equation. P denotes dou z by dou x, while s denotes dou 2z by dou x dou y. So that about the notations. Okay, that about the notations. Now come to the other part here. So this is the most important thing. You should remember this notation. Now, first article that we have is a formation of partial differential equation. So just like we form the ordinary differential equation by eliminating arbitrary constant. For example, if we have the equation like y is equal to mx plus c, where we say, suppose c is arbitrary constant. This is a straight line with the slope m, and that m is a fixed constant. Suppose the slope of a straight line is a fixed. So when m is a fixed, it is become fixed constant. Okay. When c is not, we fix here, so we say it is arbitrary constant. So it is a arbitrary constant. So meaning of arbitrary constant, it can take any value. It can take any value there. Okay, so that can change. So by eliminating one arbitrary constant, we get a first order differential equation, and that is ordinary again. Why we get ordinary differential equation? Because only two variables present in the equation. So say if we differentiate this with x, we get a dy by dx is equal to m, and that is the answer. This is the differential equation. Y dash is equal to m. So y dash is equal to m, or dy by dx equal to m, is a differential equation of a family of a straight line having the slope m. Okay, differential equation of a family of a straight line whose slope is m is just dy by dx equal to m. So that is one of the simple example of linear differential equation or ordinary differential equation. I would say this is ordinary. This is known as ODE, ordinary differential equation. But right now we are going to learn about PDE. Okay. In PDE, we can form the partial differential equation by eliminating either a arbitrary constant or arbitrary function. Arbitrary constant or arbitrary function. That is a change only. So ODE is never obtained. ODE is never obtained by eliminating arbitrary function. It is just PDE only, we can say. So in PDE, we can say when we eliminate two arbitrary constant or one arbitrary function, we get always a first order partial differential equation. Okay. By eliminating two constant or one function, we get first order PDE, but if we eliminate two arbitrary function, we get a second order PDE. Second order PDE. I will tell you in short here one thing so you can understand it. In ODE, in ordinary differential equation, number of arbitrary constant, this is a arbitrary constant, number of arbitrary constant is equal to order of differential equation. Order of differential equation. Is that we learnt already in LD? Just when we solve a third order linear differential equation, the number of constants should present in the solution are 3, that are C1, C2, C3, that all present in a CF. Is it? Is it? So similarly, in PDE, number of arbitrary function, this is arbitrary function, number of arbitrary function is equal to the order of differential equation. Order of differential equation. So that is the case. So in terms of function, yes, number of arbitrary function, if we count, that gives us the order of differential equation in PDE, but not a constant. It is a function. That is the word. Remember. But here, if we have two arbitrary constant, then we have first order PDE, that is lesser by 1 there. So we'll come to these examples. Now we have few examples written here. These are equations written, and you will observe each equation is a relation between three variables, x, y, and z, x, y, and z, x, y, and z. Because of that, when we eliminate the constant or function from these equations, we get the partial differential equation, because there are more than two variables in the equation. I hope you are getting these things. Okay. So we'll come to the question. It becomes more clear then. The question number 1 will be on the screen now. Yes. First question is on the screen. Now I want the first thing here. You can read the question. Form the differential equation by eliminating arbitrary constant of a family of spheres with center on xy plane and radius r. Now, step number 1, we are not given the equation of these spheres. So can anyone tell me which equation represents the family of spheres whose centers are in xy plane or centers are on xy plane and the radius is capital R. Yes.
The circle.
X minus a to
The
the whole
circle.
square plus
It is
y
not
minus.
circle. Okay, if you are saying circle, it is written.
Sir, x minus a to the whole square plus y minus b to the whole square plus z square equal to r square.
Yes, yes, correct, correct. I think, is it Amir who answered?
Sir, Ankur.
Ankur again. Okay, so it's again Ankur. So it's not circle. You don't say that it is an xy plane. That means it is intersection of a sphere with xy plane is a circle. That's okay. I'm not asking about intersection. We are interested in equation of spheres whose centers are only on xy plane and the radius is capital R, and the answer will be here. So this one. Now, why this is why this equation? Why this equation is that required family of spheres? You'll observe what is the center. Center is a comma b comma 0, and ab can be a arbitrary constant now because the centers can be anywhere on xy plane. So ab can be anything, but radius is fixed now. R is a fixed constant, that is fixed radius of the sphere. So we have an equation of a sphere whose centers are on xy plane, that is AB 0. So when the point will be on xy plane, then z coordinate should be 0, and that about the equation. Now our aim is to eliminate a and b. Our aim is to eliminate a and b and form the partial differential equation. So I want to differentiate this equation 1 partially with x. So can anyone tell me what will be the derivative? What should be a derivative here?
2 into x minus
Sir, 2x minus a.
2 into x
Akshay,
minus
okay,
a.
Akshay, yes, you can. Tell me. Tell me, Akshay.
Sir, which one? There are two.
Partial with x, yeah.
Sir, 2 into x minus a
Yes,
plus 0.
very good.
And sir, what's this is C, sir?
No, it is z, na? It is z.
Oh, yes, sir. Sir, and sir, plus 0 is equal to 0.
Not correct, not correct. Because you should remember throughout this topic, z is not independent variable. Z is dependent variable. Z is a function of xy.
Sir, 2z into
2z
dz by dx.
Correct, okay, no issue, correct. Akshay, it's okay, but you should remember
Dou
that
z
thing.
dou x.
Okay, 2z into dou z by dou x. And now the RHS derivative is 0. So when we differentiate this with x, you will get this part. First of all, derivative of this bracket is a 2 times x minus a. Derivative of this term is a 0 because z is a function of xy. Y is like a constant as we differentiate with x, and it becomes 2z dou z by dou. So when we simplify, we get the value of this bracket x minus a can be written as a minus z into p. Can you tell me similarly what will be the value of the other bracket?
2y minus b is equal to minus 2z cube.
Okay, correct. And simplifying, we get y minus b is equal to minus z cube.
Minus z cube.
Correct, correct. Very good. So similarly, differentiating partially with y. So now we are differentiating partially with y. This equation 1 only. Derivative of this first term is a 0. Derivative of second term 2 times y minus b is 2z dou z by dou, and that we get this value. Now the last step is left. Our aim is to write one equation which is a free form a and b. So how you can write with the help of 1, 2, 3? With the help of
Sir, find value of a from 2 and b from 3, then substitute it in 1.
not required, not required. Now, why should only a? You can directly replace the bracket value, no? Why again to make complicated? That is also okay. You are saying that is okay, but you can replace direct x minus a as a minus zp there, is it? And y,
Yes, sir, yes, sir.
y minus b directly you can replace minus zq there. So that's one. So you'll get the final answer here. So when you replace it, you'll get the answer. So the answer you'll observe, we replace that is a z square p square. Okay, z square p square, and z square is taken common, and this is actually the first order PDE for the given equation or for that family of the spheres. If anyone have a doubt, yes, you can ask. So complete it. Once you finish writing, you can tell me. We'll move to the next question then. So how many of you completed? How many of you finished?
Answer.
Done. Okay, nice. So move to the next question then. Question number 2 is here. 2z equal to x square upon a square plus y square upon b square. Now you can tell me the step. How many arbitrary constant here?
2, sir.
There are two, correct. So because nothing is written about a and b, so they are arbitrary constant. They are a and b notation. So we assume they are two arbitrary constant. This may be the equation of ellipsoid. So we're not going in what it represents. No, that is not our interest right now. We are interested in forming a PDE. So step 1, differentiate this equation partially with x. What should be the answer? Yes, differentiating partially with x. What will be the equation we get?
So 2 dz by dx
Yes,
equal to 2x upon a square.
very good, very good, correct, correct. So yes, the answer is correct. So indirectly we get p is equal to x upon a square. P is equal to x upon a square. Similarly, what will be the value of the q?
So y upon b square.
Correct. So when we differentiate partially with y, we get a new equation as a q is equal to y upon b square. Now we have equation 1, 2 and 3 and our aim is to eliminate that a and b. So what will be the answer?
2z is
So
equal to p
xp
square.
plus yq is equal to 2z.
Yes, very good. xp plus yq is equal to 2z is the answer. Okay, because when you replace x upon a square by p here, 1x is already there. So xp plus yq, that's what. So the final answer will be like this. So you'll observe that by 1, 2, 3, 2z equal to xp plus yq. Okay, xp plus yq is there. That's what. So again, we got here first order PD because there are two arbitrary constant.
Answer.
Done. All of you completed. So can I move to the next question? Next one then. Question number 3. Yes. How many arbitrary constants are there? Yes. How many arbitrary constant?
So 0.
0. Yes, good. Yes, there is no constant. So what is there? Instead of arbitrary constant, we have
Function.
arbitrary function. So f is arbitrary function and that we have to eliminate now. This arbitrary function we have to eliminate. So one arbitrary function indicates first order PD, is it? So our aim is to find again partial derivative. So can you tell me what is the differentiation of this with respect to x?
So dou z by dou x is equal to f dash x square minus y square into 2x.
Very good, that's correct. So first dou z by dou x is equal to derivative of f with respect to x is f dash because f depends on x and y. So first it is f dash into the derivative of bracket, that is a chain rule. So into 2x you should write it. That you get a derivative here. So it's just derivatives. So this is dou z by dou x. That about with x. Similarly, we get a differentiation with y now, and that will be dou z by dou y is equal to f dash of x square minus y square into the derivative of a bracket, that is a minus 2y. So don't forget to write minus 2y. Now we have equation 1, 2 and 3 and our aim is to eliminate that arbitrary function f. So what should be done?
Divide 1 and 2 and 3.
Very good. Yes, divide 2 and 3, Raj. Yes, you are correct. Very good. So that's a good observation. If we just take equation 2 upon 3, f dash will get cancelled and we get equation which is 3 from f, which is 3 from f. So we don't want a final relation, in final relation that f should not be present in any of the form. So it should not be in the form of f or in the form of their derivatives. It should be free from arbitrary function completely. So the answer will be this one. So when you divide and cross multiply, py plus qx equal to 0 and that about the differential equation corresponding to given equation. So once you complete, tell me. We are going to take one more example on this type.
Done, sir.
Done? Okay, very good. So the question is on the screen. Z equal to x f of y plus y g of x. How many arbitrary functions are there? Yes, Amey.
So two arbitrary functions
Yes.
f of y and g of x.
Very good, correct. So which order differential equation it will create?
Second.
Second
Second
order.
order. Sir.
Second order, not first one now. It is the second order differential because number of arbitrary functions is equal to the order of differential equation. So two arbitrary function is second order. So in this case, we don't have to calculate only the P and Q. We should calculate the values of all R, S, T also. So total 5 derivatives we have to compute. So step by step, tell me first, what is the dou Z by dou X? What should be dou Z by dou X?
So f of y plus y into g dash x.
Correct, nice, good. So similarly, we can get dou Z by dou Y also. So I'll show you here. These are the values of P and Q. Dou Z by dou X should be this one, dou Z by dou Y should be other one. Is it? Just term by term derivative is taken. Now can you tell me what is the value of R? That is dou 2Z by dou X square. To get dou 2Z by dou X square, we have to differentiate this dou Z by dou X again with X. Differentiate this with respect
Sir,
to
y g double dash x.
not correct. Not correct. So this is the
Sir,
synonym.
0 plus y into g double dash x.
Okay, sorry. First, who said y g double dash x? That's correct. My mistake. Yeah.
Yes.
Yes. Okay. Y
Ankur
g.
said, I guess.
Ankur said it is y g double dash x. Correct. That's one. Because the derivative of fy with x is a 0, so it is y g double dash x. Good. And what about the value of s, which is the dou 2z by dou x dou y?
Sir, f dash y plus g dash x.
D dash
Yes.
for
Yes.
X.
Correct. Correct. And similarly, you get the value of t also. I'll show you all these values are here. So you'll observe by 2, 2 and 3. Okay, so that we get values of RST. Now we have the equation 1 to 6. Okay, there are total 6 equations, and our aim is to eliminate that arbitrary function f and g both. Okay, we want one relation which is free from f and g. So what should be that answer? So second order is generally tricky. Yes, any answer? One. Second order, yes, it's always a little bit tricky there. You have to think on it. One is able to get the answer. You can see here that original equation 1, this equation 1, then these three, all equations you have the careful observation and what should be done so that you can eliminate that f and g there.
So the eliminated equations would be free from fy and gx, right?
Uh, yes, final equation, final answer, equation or answer should be free from f and g. Also f dash and g dash, nothing should be there. Okay. will wait for last 30 seconds. I will wait for 30 seconds for the answer. Otherwise, okay, I will start with some hint. Okay, no answer. Someone said adding 2 and 3. So just addition of 2 and 3 will not fulfill our thing. Yes, little bit correct, Asif, but it is not completely correct. Not only we have to add 2 and 3, Asif, what should be?
Multiply x.
Yes, multiply x and y. Very
2.
good, very good. Correct, Raj. So this is the a good observation that Raj that you'll observe here is x f y and there is y gx. So if you want here x f y and here y gx and then we add, so we should multiply equation 2 by x and equation 3 by y. So x into equation 2 plus y into equation 3 will gives us the required answer, and you can see how it removes all f and g there. So here is a solution. So we'll observe xp plus yq is done. So x into equation 2 plus y into equation 3. So we collected the terms of without derivative, that is xfy plus ygx, and in remaining we can take xy as common. We're left with f dash plus z dash, but we will already have the value of f dash plus z dash from the equation 5 as s. Okay, from equation 5, that is s, and original equation is this one, equation 1. So we got xp plus yq is equal to z plus s into xy, and that is a second order differential equation. Second order differential equation for the given equation there. That's what. So generally the second order is always a tricky this one. Because you have a very good observation in so many equations, and sometimes it becomes simple also. Sometimes what happens when you take a second order derivative, already all functions are eliminated. All functions are eliminated there, and you get directly the answer without using any other equation. So sometimes it may happen you will get like dou 2z by dou x square is equal to 5. You got like this. So nothing, you have to do it now because dou 2z by dou x square is r. R is equal to 5. That is the answer only. R equal to 5 is the answer. Sometimes that also be possible. Or you will get dou 2z by dou x square equal to minus f, and dou 2z by dou y square equal to plus f, and then you add it and you will get r plus t equal to 0 that way. So we'll not go in the detail there, but another important thing, on formation of differential equation in last 4-5 years not a single question asked. Okay. There is I will tell you that not for a single mark, that is one question is asked on this formation, but even though the questions are not coming in the exam, this article is very important to understand when you write the solutions of differential equation later on, because in the first part of this topic, what we are going to do it, we are going to just I will write it. We are going to solve first order or linear, say linear or first order PDE. Okay, linear PDE. Then we are going to write its solution of first order partial differential equation. So can you tell me the solution will contain how many constant or function? When we write its solution, the solution must be in the form of yes. No one is giving the answer.
What's the question, sir?
The question is, when we are going to solve now in the next session the first order partial differential equation, then its a solution should contain some constant or the function. Na? So what should be the number of them?
Sir, 1.
What is one? One for constant or function?
So one function.
One function. Yes, it is a first order PDE. First order PDE solution will contain one arbitrary function or two constant or two arbitrary constant. Remember, whenever now we are going to solve from probably the next session onward first order PDEs, our solution can be written in the form of either in one arbitrary function or two arbitrary constant. Okay, but after that, when we solve higher order differential equation, then the number of arbitrary function is equal to that order of differential equation that will come in the solution. Right now it is just like a solution. In the screen it is written z equal to x fy plus y gx. It contains two arbitrary function. As it contains two arbitrary function, it corresponds to the second order differential equation that we observed here at the end. So at the end we have xp plus yq is equal to z plus s into xy. So that's S itself S only indicates it's a second order differential equation, because highest order differential coefficient present in the equation is S there, and that is a dou 2z by dou x dou y. Okay, that is a S there. And that gives us the order of differential equation. Okay, so